class, and today we are doing the Chapter 4 final review. The first thing that we're going to be doing is we're going to be multiplying fractions. Let's look at my example. I've got 1/3 times 2/5. So in our last lesson, we learned how to multiply and divide with decimals. Now we're keeping them when they're fractions. How do we multiply when they're fractions? This is important. How do we multiply? Do we multiply them a specific way? Is there a specific thing that I need to do? Do I have to pay attention to certain numbers? What do I do? So Emmett says multiply horizontal. Horizontal is that way, by the way. So Emmett is correct here because what we're doing is we're going to be multiplying across. So we hear that before. We've heard multiply across. So I multiply 2 times 1 and I get 2. And then I multiply 3 times 5 and I got 15. There we go. Simple as that. What about if I had one like this? 3/10 times 5/6. What is my answer gonna be? So as I said to hit enter for your best answer, I got Emmett, Hannah, Maddie, Fernando, Izzy, Sophia, Carmen, Ani, Angel, all put 1/4 because all of them outsmarted me and beat me to the punch. So, yes, that is exactly what we get. Now, wait, I don't see, how is this going to make 1/4? That makes no sense. Oh, we need to do something. Yes, we need to cross cancel. So, first things first, if you didn't cross cancel, you can fix that later. This would become 15/60ths, and you need to find the GCF of those two numbers. However, that can be pretty inconvenient because the more you multiply, the bigger your numbers are, and quite frankly, doing that step first is just inconvenient. So if I would mark that down, it's just inconvenient. But what we can do is we can cross cancel beforehand. So when we cross cancel, that's when we're looking at this. And I think, so I look at these two sections and I'm looking at the 5 and the 10 because those are crossing. You know, it forms like kind of that cross right there. And that 3 and that 6. What I do is I find the GCF for those pairs. So I got this 3 and the 6. Hey, that's easy. The GCF is 3. I divide each by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Do the same on this other side. Hey, the GCF is 5. Hey, look, 1, 2, la, 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 la. Then we multiply. 1 times 1, 1. 2 times 2, 4. Awesome, you guys. Let's do it again. Let's try this one. What about this? 5/6 times 15, let's see, 8ths. That's better. 5/6 times 15/8ths. So I'm going to do this, right? So you're going to tell me. I'm going to cancel out. Here's the 5 and here's the 15. I know the GCF is 5. So this is going to become a 1. This is going to become a 3. And I'm going to get 3/48ths. Bing, bam, boom, done, right? No! What? But I thought I did it right. What did I do wrong, you guys? What? You guys are making me all confused. What did I do wrong? Yes, as Emmett wrote, you cross cancel, not across cancel. Exactly. We cannot across cancel. We cross cancel. So in this case, we have to cross cancel. 5 and 8. 5 is already prime. 8 is not divisible by it. So those two numbers stay the same. They're there. 6 and 15. Do those have any greatest common factors between them? So we already know neither of them are prime, so they have some numbers. Let's see their GCFs. Find their factors for me. So just like we did in Chapter 1. Excellent. So you guys found the GCF. I got Izzy, Maddie, Hannah, Emmett, Ani, Sophia. All said 3 is their greatest common factor, which is correct. 1 and 6, 2 and 3, 1, 15, 3 and 5. So when I cancel out that 3 on the 6, it becomes 2. When I cancel out that 3 on the 15, it becomes 5. Notice that it's the corresponding pair. So then I multiply across. I now get 25 over 16. Am I done yet, or is there something else I need to do? So Madison says I need to simplify. But I already cross-canceled. I already did that. What more do I have to simplify? Gosh, you guys are making me do so much work. What do I need to do? I think all of you guys are having brain farts. This is a fraction. What kind of fraction is it? What kind of fraction is it? As Hannah says, it is an improper fraction. We don't leave things as improper fractions. So we need to solve it. How do I go from an improper fraction to a proper fraction, which is called a mixed number? What do I need to do? So I got Hannah that said subtract numerator from the denominator. She meant denominator from the numerator. And then I've got Izzy and Madison that said divide. Fernando said divide top by the bottom. Yeah, there's actually both of those ways work. So if I had this 25 over 16, Hannah's way, I took away a 16 and I'm left with 9. So I took away a 16 over 16 and I'm left with 9 over 16. What that means is I have 1 and 9 sixteenths since I took away one of those sixteenths. Awesome. That's a great way. The problem with that one is that sometimes our numbers are really big and it just gets inconvenient. Otherwise, here is what we do. We have 25 divided by 16. How many times does 16 go into 25? It goes into 25 once. We subtract, we get 9. What this is here, this is our new integer, this is our new integer, 1. This remains our denominator, 16. And this, the remainder, is now our new numerator, 1 and 9 sixteenths. With Hannah's method, you just keep subtracting until you get down to a proper fraction and count how many times you had to do that subtraction. So if repeated subtraction is easier, do that way. If division is easier, do that way. So both methods are correct. Notice that in math, there are lots of ways to get the right answer. So exactly. So that's how we go from an improper to a mixed number. How do I go from a mixed number to an improper fraction? What if I had this, 3 and 3/4? How do I go from 3 and 3/4 to a improper fraction? Madison, what do I do?
You add the numerator. No, wait.
Ooh, you're jumping a step, but yes, you are there. So she said you add the numerator. Okay, so she gave us a hint. We have to do something. And it does later involve adding to the numerator. Nathan says multiply the denominator and add the numerator. I need to know what to multiply the denominator by, but he's using correct math words. Here's what we said. Both Fernando and Sophia and Izzy, they wrote that 4 times 3 plus 3. If we were to explain it using our math terms, just like Nathan did, we are going to be multiplying our integer, the big number, by our denominator, and then adding that to the numerator and keeping the denominator. So it sounds super tricky. Multiply, then what we get there is we add. So in this case, 3 times 4 is 12. Then we add that to 3. So 12 plus 3 equals that 15, and we keep the denominator. If you didn't trust me, let's go backwards. 15 divided by 4. 4 can go into 15 3 times. That's 12. Our leftover is 3. Big number, numerator, denominator. Oh, hey, look, it matches. So, the way I like to remember this, and I know that this can be a little challenging, but this is where I do this, so I do plug and play numbers. We like to do plug and play. So if I've got A, B, and C, what it becomes at the top is A times C plus B all over C. So all that is right there is a nice template for you. So if you write that down, that's a nice template. Whatever number you have here, you multiply it by whatever number you have there, and then you add that pairing to this, and our denominator stays the same. Notice the denominator stayed the same from going from improper to mixed and from mixed to improper. Denominator stays the same. That's it. Denominator stays the same. Now, I've got a question. Now we know how to go. We know how to multiply. It's really easy. We multiply across. We know how to simplify. We cross-cancel beforehand and do our GCF. We know how to go from improper to mixed and mixed to improper. What about this? I want to know how to do this. What is 1/2 divided by 2/3? 1/2 divided by 2/3. So I want you guys to think about that for a second.
Yeah.
Madison, what did I do wrong?
You forgot to change the divide symbol into a multiplication symbol.
Oh, okay. So I see what she said. So I needed to do this. So I have it all right so far. And then I've got my 1/1, and now I've got times 1/3. Okay, I got it now. Wait. What is he? We're having problems still?
Okay. First, you must keep the first number.
Uh-huh.
Then, you change the division
Oh.
multiplication.
Okay.
Then, you flip the last number so it's 1/3.
Oh.
Or 3.
Titan.
3.
Oh, so that's what I do. So that's what Madison was getting at too. So I keep my first fraction. In fact, so I keep this 1/2. I multiply, and then I change that, and then I flip this. Hey, was I supposed to cancel those out? No, you cannot cross-cancel when dividing. You can only cross-cancel with multiplying. And look, there's nothing I can cross-cancel. I get 3/4. There I go at the end. Keep, change, flip. Or Kentucky Chicken Fried. Who can tell me, when I flip it, what is it called? So, for example, 2/3 flipped became 3/2. What is that called? If this is my original, what is that called? So as Hannah wrote, it's our reciprocal, or as I like to remember it, the reciprocal. Because all I did was I flipped our two numbers. So what if I had this? 10/7. My reciprocal, my reciprocal is 7/10. That's it. It's just flipped. By the way, when you multiply your original by your reciprocal, you get 1. Pretty crazy, right? Okay, now I want you to look at the next thing. Let's do, here we go. Here's our nice little graph right here. I'm going to make a line right there. I'm going to make a line right there. We're going to talk about this. There's 4 quadrants, okay? There's 4 quadrants when we're doing math. First, which axis is my x-axis? Which one? Is it this one or is it this one? Is it axis the first one or the second one? Which is my x-axis? Yeah, Hannah says the horizontal one. Ooh, Izzy says the dead man. I love that. In a different video, I made it look like this. Here's our dead stick man, and look, he's got X's for eyes because he's dead and he fell down. Yes, so that is our x-axis. I love when you guys use these memory tricks. And our y-axis, hey, look, it's got that up and down. It's got this up and down, so those two match as well. Now, this is something good to take notes on. Here, both of our x and our y are positive. Here, our x is negative, but our y is positive. Here, they are both negative, and here, our x is positive and our y is negative. You can figure that out just by knowing that the top half of our graph means y is positive, and the right half of our graph means x is positive. So that's just what we're doing there. Now, we're going to talk about this. There are 4 quadrants. There's quadrant 1, 2, 3, and 4, aptly named. Now, I want you guys, what is this quadrant? What is that quadrant? I'm going to call it just quad. What is that quadrant? Yeah, I see Sophia and Izzy said 1. Excellent. Where is quadrant 2? Oops, as I'm spelling it wrong. Quad. Where is quadrant 2? Is it A, B, or C? Which one's quadrant 2? Nathan says A, Izzy says A, Carmen says A, Isa says A. Yes, this is quadrant 2. This is quadrant 3. This is quadrant 4. It goes around counterclockwise like that. There we go. Now, that's all there is to that when we're doing that. What about this? Here's what I want to know now. We're going to talk very quickly about one of my favorite things, because it's so easy. Absolute value, as I like to draw it in these little lines. Absolute value. Whatever my absolute value is, what's the rule? Whatever number my absolute value is, it is always what when it comes out? It is always what? Excellent. It always comes out positive. Always. Any number put in there. So as such, what about this? What about -8? What's that equal to when I put it in there? 8. What about absolute value of 8? What's that equal to? -8, right? Right? No, it's still 8. What about this one? If I had something different, like if I had negative absolute value of 8, what's that equal to? Negative absolute value of 8. Izzy says -8. Hannah says -8. Melanie says -8. I thought absolute values always had to be positive. Yes, inside the absolute value has to be positive. Exactly, Hannah. Only if it's on the inside. Absolute values work like parentheses. We follow that in order. So we follow parentheses. There's no exponent, and then this is being multiplied. Lastly, what if I had absolute value negative, or if I had negative absolute value of -8? What is that going to be equal to? What's that going to be equal to? Again, -8. Perfect, you guys. Look at that. You're nailing that so much. Now, the last thing that I want to cover today, so some of this was chapter 5, just this and our absolute values, which we will continue to be looking over, were part of chapter 5. So, based on that, when we review what we did today, for our chapter 4, we multiplied fractions and we divided fractions. We learned about keep, change, flip, Kentucky Chicken Fried. We learned about cross-canceling. We learned how to make improper into proper and or into mixed numbers and mixed numbers into improper fractions. That is all that chapter 4 is. Congratulations, you guys!